लेटवा के जला रसोई में बेटा लेटवा दोनों जगह बंद कर देते हैं नहीं बोतल में ले ली पानी ये चीज गिर जाता है तो सर ढक्कन किधर है तो बोतल को एक जगह बांध के रख दी तू जरा सा दे दे कौन सी है मिर्ची है मिर्ची मेरा मिर्ची और मिर्ची वाली आते तो बोल रहे हैं अब ये मेरा नेट ये चल रहा है कंप्लेन कर दिया आएगा अभी पता नहीं कोई वायर टूट गया है वायर खींच दिया इसने वायर खींच दिया कपड़ा धुला है क्या वायर धुला ना दिमाग खराब है खींच दिया हमें से टेंशन ये कि कोई कहां से कपड़े तो मैं धोए सुखाए कितना दिन से धोई बेटा कपड़े धोई नहीं सुखाओ कपड़े कपड़े तो पानी में डाल के रख दो नहीं लिए हैं कि इनके दिमाग में घुस गया सुबह सुबह हम बोल दिए नहीं लिए खाली अंडा लेके अकेला तू नहीं बोली तो मैं क्यों बोल रहे सुबह लिए खाली अंडा लेके ही है
Yes, good morning, everyone. Am I audible at the back? Am I audible, everyone online?
Yes, ma'am, audible.
Yeah. Okay. Okay, we'll start. So, record.
This conference will now be recorded.
GVM is not there. Okay, so okay, we'll start. So all of you have completed Verilog sessions, right? What all projects you have completed? FIFO, interrupt controller, memory, SPI controller. Okay. So how did you write verification environment for it in Verilog? You must have verified your design, right? Yeah. So how did test bench? What did you write in test bench? Test case. Before that, you must have thought of a process, what to do. What did you think about it? I mean, if you have a design, what all do you have to do for that? Yes, include design. Yeah, but you must have looked at signals. You must have looked at ports. You must have understood what is the functionality of those signals, what they are doing inside the design, right? For example, memory. What did you think about writing test bench? What did you have to do to verify memory? Yes, write into the memory using the handshake, right? Read from the memory, right? So how did you come up with that? How did you have the addresses? How did you have the data? I'm sorry, address port, right? So you must have directly put the data on address port, correct? Address and data, both of them, correct? Address port, data port, you must have directly accessed them, right? Did you do all of those things in test bench one file, one module? You must have given value or assigned value to address port in the same module. You must have driven those data to the duty from the same module, right? You must have done the analysis as well. Did you compare whatever you have written into it is what you are reading out of it? Did you compare? Right? What about online students? What all did you think? What all did you think? Can you tell me in kind of a flow chart? What did you think? You have a memory design. Then what did you do? You generated clock and reset signals for it, right? Then instantiated the design, right? You initialized it, right? With reset equal to 1, what did you do? All memory locations to 0, right? Then you started putting the data on it using the port itself. Did you write a task? What was the task? Write to memory, read from memory, right? You must have written a backdoor access task, right? So all of those tasks, what you did here was in memory design, verification was done all in one module, right? Starting from generating the stimulus. What do we call assigning values to the port? We call it generating the stimulus, correct? Generating the stimulus, right? Then what did you do? After generating the stimulus, you must have assigned it to the port, right? So driving it to the duty. What do we call it? Driving it to the duty. What else did we do here? Analysis. Whatever we have written. Analysis of written and read data. Whatever we have written into the memory should be matching with the data whatever we are reading out of the memory at that particular address, correct? So if it is matching, we were displaying something like test passed, right? And if it was not matching, we would write test failed, right?
Hello,
So all of
sorry.
that
Hello,
is done. Yes.
can you just little bit bigger your text editor? It is slow. I mean, it is small.
You're not audible actually properly. Can you ask the question again?
Your text size is small. Can you little bit bigger? Means 13, 14.
Okay. Is this fine? Is this better?
Yes, thank you. Thank you.
Thank you. So yeah, so analysis, all the verification verification processes were done in same module. Everything in the same module. Now memory is to an extent a simple design. If you want to write into it, you can write into it with that task that you have written, read from it. Only two things to be done. What about interrupt controller? There was programming of the register, right? Then actually processing the interrupt, right? For a bit complicated design than memory, we would need more processes to be done, right? And all of that in the same module, right? For interrupt controller also, you must have written the test bench in the same module, one file, everything. So it becomes a bit confusing. What about SPI controller? The same thing, right? There was programming of the register, then actual functionality, right? So in all of that, as the complexity goes increases, right? As the complexity increases, we are going to have to write more and more functionality in the same module. It is going to get confusing. What if you had something like UART in a design like UART? Right? You have 8 registers to be programmed, 7 registers to be programmed, right? And all of them, I mean, in each of the register, you have few bits representing a different functionality. What is the baud rate? What is the data length? What all things you want to control about your transmission? All of that you need to configure first in UART design. Once you have configured, what you do is you implement the verification. If according to whatever you have configured, is it working fine? So here analysis is going to become more complicated, right? You have more things to be verified. I am configuring my UART to be transmitting 5 bits at a time. So there is start bit, there is end bit, there is middle data of 5 bits, right? So all of that needs to be programmed, correct? All of that needs to be verified also later. Whatever you have programmed, is it the same thing that you are getting, right? So things are going to become complicated as you go further and further in complications. Like there are USB, Ethernet, more complicated protocol, more analysis part you will have to write. So Verilog becomes a bit uh, restricting language, right? So with all 7 registers, we have different functionality to be verified, right? As the complexity of the design increases, the verification in same module becomes complicated and difficult to keep track of. Verilog is thus restricting language for verification. When did the complexity start increasing? As we started including more and more features to our electronic devices, right? So this is long back that we developed, we meaning companies developed system Verilog language for specifically verification purpose, right? Specifically verification purpose meaning what we need is specific in verification, right? We need stimulus generating, we need data driving, we need constructs that will be helpful to us, that are pre-written, that will be helpful to us while driving the data to the duty, right? We don't have to, there will be different modules for doing the analysis as well, right? So let me open the PPT. Just
नहीं तो ये पहन ले ले ये पहन ले फिर उसके ऊपर ये पहन ले
just a minute.
Hello, ma'am. Your voice is not
Yes,
audible.
yes. Yeah, tell me. Hello.
No. Hello, your voice is not audible, ma'am.
Can you repeat?
Okay, ma'am. Okay, ma'am. No problem.
No, can you repeat what you were saying?
For 5 minutes, your voice is not audible, ma'am. No, it is
No,
clear,
I was
ma'am.
actually not talking. I'm trying to log into the InScale actually. Just a minute.
Okay, ma'am. Okay, ma'am.
Got it. So we have. Right, you can see. So what System Verilog does is System Verilog helps us write verification environment in a much simpler way. Right? How did you complete Verilog course? What all things that you did from your side? There were lectures, theory lectures here. What did you do on your side? Yes. What did you do from your side? There were theory lectures then. You must have done something from your side. Did you solve assignments? Did you practice the concepts on your own, coding concepts? How did you do that? For example, I gave you array concept in Verilog. How did you practice array? You must have instantiated array, right? You must have instantiated array of vectors, array of integers, right? You must have done operations with it. You must have tried to do addition. You must have tried to do some operation, right? So there was a lot of, what if I just tell you the concept and that was it? Would you understand? If I ask you to write the code just on theory concept, would you be able to write the code? Would you be able to write the syntax? No, right? You have to practice from your side, right? So to complete Verilog course, what you must have done? Attend theory lectures. What did you do then? Attend labs, right? Do assignments. Did you do something on your own to try and demonstrate the concepts? Whatever theoretical concepts you have learned, did you try and demonstrate on your own through the code? Try coding concepts on your own. Now, this last point that I have written, it is very necessary. Even if you have not done it for Verilog, it's very necessary in System Verilog because System Verilog is base. System Verilog will help you understand UVM. It will make your UVM course much, much easier. If you do this properly, you're going to feel that UVM is much easier than a lot of people otherwise do. So while going through SV course, what all things you should do? What all things you should do? First is attend theory sessions, right? Then attend labs. A lot of people skip labs. I have taken theory sessions, I have taken lab sessions. If theory sessions have 40-50 strength, lab sessions will be 4-5. Literally 4-5. Lab sessions is very important in system Verilog. If you, and I have seen only those 4 or 5 people ultimately have the understanding of system Verilog, then UVM. All the rest of it are struggling with system Verilog course for months together. They are struggling with basic concept of system Verilog, right? So whenever you have started now system Verilog, it's your responsibility. Whatever is covered in theory session, you have to practice it on your own. And to help you with it, there are lab sessions, right? Attend lab sessions. Lab sessions will cover what all things lab sessions generally cover? Assignments, right? Or they also cover concepts, coding concepts, right? Coding, the concepts, right? They also cover that. What else? Your doubts, right? If you have any doubts, they are covered in lab sessions, right? You ask your mentor, I didn't understand a particular execution, or I'm getting this particular error, I'm not able to resolve. Did that happen? Right? So lab sessions are utmost important in system Verilog. Okay, you have to attend them and then do assignments. This is basic actually. If you have not completed assignment, you won't be you won't be going to the next course, that is UVM, right? You need to complete it and submit it, right? So after the assignment, something extra that you need to do is, theory session is going to be what, 3-4 hours, right? 3 hours, not 4, 2-3 hours at max, right? Not more than that. After that, you have entire day. Lab session another 2 hours, 2-3 hours, right? Entire day you have to practice the concepts, right? It's very important that code. For example, if I tell you that arrays, elements of arrays cannot be, right? Arrays together cannot use addition, arithmetic operators, right? I cannot do array. Let's see. Code. Right. I cannot do integer a comma b, a 3 down to 0, right? And I have integer b 3 down to 0. Tell me if this is possible. Is this possible?
No, ma'am.
Why is it not possible?
No, ma'am, because they are arrays.
Their functions are not possible.
On unpacked arrays or on arrays, can we use arithmetic operators, any arithmetic operators? Can we do it this way? No, right? We need to access individual element. Now, this concept is simple enough to understand. We cannot use arithmetic operators on arrays, but you need to try and use it in the code, because there are a lot of students who in System Verilog mock interviews do the same error. They declare arrays, they add them together. This is not, and while learning the concept, you will laugh at this mistake. But after you are done with System Verilog course, you forget those basics. There are more complicated, or what can we say, important concepts for you to consider in your revision, right? You forget these concepts. These concepts are not forgotten only and only if you have done coding for that. You have actually experienced what error will come. If you execute this code, you will get a particular error, right? You need to know what that says. You need to read each and every error properly. Keep it in your head. Okay, if I do this, this is what I'm going to get in transcript. And how to get rid of it? By removing this line, or by accessing, if addition is what is expected of you in that code, then you need to access each element individually. Correct? It's very important that you debug your own code. Very important that you learn debugging. How will you learn debugging? Not just by making mistakes. Every mistake doesn't have to come from you. when you are attending lab sessions, your friends will make a lot of mistakes for you. You can try and debug them, right? You will have what, a lot of people in the lab session joining, right? They'll be doing mistakes, I'll be helping them, or your system verilog lab mentor will be helping them resolve it, right? So what is your job? To think, how could I resolve this error? Keep in mind, okay, this was the issue, that's why he got that error or she got that error. I need to keep in mind, okay, next time I get this error in transcript, I can resolve it by looking at this particular thing. Maybe this is wrong, right? So you need to learn these things, and these things nobody will teach you in theory session. Nobody will teach you in lab sessions also. Your mentor will also, what he will be doing, he or she will be doing is, they'll be helping the student who has that error. They won't tell you, okay, this is okay, because it's literally spoon feeding if they have to tell you. You need to do it on your own. If you see an error in lab from a friend, you try to resolve it, right? If the solution that you have provided is not working, doesn't matter, right? You are learning. Your mentor will solve it. You will know, okay, this is the solution, correct? So it's very important that you do all of these things. Only learning in theory session, only learning in theory session and just attending lab session, okay, is not enough for SV. You need to participate. If a mentor, lab mentor is asking you, okay, show me what you have done, you need to show. You don't have anything to be embarrassed of, right? You can show, okay, this is what I have done. Mentor will be able to help you as to how to rectify things or how to do things faster. Next thing that is important is learn GVim shortcuts, right? When you are coding in Verilog, right, you have learned only limited number of coding. What was the maximum number of lines in your test bench? 50, 60, 70, 100, 150, right? Not more than that. But in System Verilog, number of files is going to be more. You will be coding much more than you have coded in Verilog. So GVim shortcuts is very important for you to know and be able to use. So from lab day one, if you have GVim shortcuts file with you, right, from Verilog sessions, maybe first few sessions they must have given you that shortcuts file. Use each and every shortcut. It will take time for you in the starting, because you have to remember, okay, this is the shortcut I have to use and this is how I have to use it. It will take time, but once you get the habit of it, it will make your life much simpler and your coding faster. Your speed of coding tells the interviewer how much you have practiced coding, how much you have worked with System Verilog. Your speed of coding is very important. You will get the speed if you are using shortcuts. Okay, learn GVim shortcuts by practicing from day one. Right? In the starting, it will be slower than what you have done before in Verilog, right? Slower. But as you get habit of it, it will be faster than before. Okay, your coding speed will be improving. Okay, so it's necessary that you practice each and every GVim shortcut. Okay, so all of these things are expected of you on your own. I have told this to you today. No one will tell you later in lab, okay, you're not using this shortcut, right? This is something I have told you. This is going to help you practicing concepts on your own, demonstrating concepts. If someone is telling you that this is how System Verilog, a particular construct works, then it's your job to see if it is working the other way. If it's your job, if someone is saying that without allocating memory, you won't be able to use a particular object, this is something you will learn as we go further in the sessions. Okay, so it's your job to see what if you don't allocate memory, what will happen if you don't allocate memory. It's your job to see that what will happen in the transcript, how to get rid of it. It's important that you, without even mentor telling you do this, you should be doing this. Okay, so with practice from your own side and help from trainers and mentors, you will be able to grasp SV concepts faster. Okay, it's very important. Okay. So let's let's see, now that I have told you what all you need to do from your own side. So let's see how system Verilog is different from Verilog. So far, what we have done. Okay, so in Verilog, you were writing all the verification processes or methods in the same module. You were at max to compress or make the code easier to read. What you were doing, you were writing methods. Okay, this is methods name were simple enough to understand. Okay, this is what is happening here, writing to the memory, reading from the memory. But what System Verilog introduces is object-oriented programming. Very important. SV introduces object-oriented programming. What is this object-oriented programming? How it is helping us? All of that will be covered later in the detail. I'll tell you the gist of it. What is object-oriented programming is, it helps us modularize the code. It helps in getting modularity. What do you understand by modularity? You hear the word modularity. What do you understand? You can try, it's okay if it's wrong. Online students, what do you understand when I say modularity? Modular. Have you heard of modular kitchen? What does it do? Order. Correct. It compartmentalizes. It gives a particular job to a particular module, right? When you think about modular, what you think? Let's just take example of kitchen only, okay? What is the difference between normal kitchen and modular kitchen? Normal kitchen just has big compartments and in which you put utensils or containers, right? What does modular kitchen have? It has separate compartment for spoons, for bowls, for glasses, for plates, for everything it has separate compartments, right? So separate space is allotted for every type of utensil, right? So modularity, what do you think that has to do with test bench verification? Modularity. Correct. So what modularity does is, it brings order or it gives separate job to a particular module. Not module as such. Don't think of modularity with respect to Verilog module. It's different. Okay. Think of a component. There is a component. It gives specific job to specific module. I'm going to write module here and explain. Do not confuse this module with Verilog module. Okay. Just think of module as compartment. Module means compartment or component. It's not visible, right? Or component, right? So what it does is it helps you give specific job to specific component. Now, for example, we have generating the stimulus. There is a component dedicated to just generating the stimulus, right? In memory, you must have seen there are different requirements, right? You are accessing maybe 1/4 addresses, then next 1/4 addresses, or maybe you are accessing backdoor, right? So they are different stimulus, right? Different, their random data has to be generated in different way, right? The address range is different, whatever can be difference there, right? But there is difference, right? Similarly, when you are configuring maybe priority to your interrupt controller, you might have one priority where smallest number has smallest priority, largest number has largest priority. Second can be largest number has the smallest priority, smallest number has largest priority. Other can, last one can be random. So all of these three programming configurations are different test cases. You must have written it in terms of different test cases, right? So these are different stimulus altogether. As you go further and verify more and more complicated designs, you will see that you need separate stimulus generation for separate test cases. So generating stimulus is one big job. As we go further, we will require more and more number of lines in generating stimulus only. So generating stimulus can be a job given to just one component. That component will do only that much. There
Ma'am,
will be a connecting. Yes.
Ma'am, stimulus means what, ma'am?
Stimulus means random data, random generated data. Stimulus means, see, your design has input ports, right? Those
Yes,
input
ma'am.
ports expect you to provide random data to it, right? That is stimulus. Now, it doesn't actually have to be random. When I'm accessing memory, I will be accessing a particular address. That address has to be provided to the DUT by me. So that's why it is stimulus. I'm giving it stimulus or random data to be used internally. Correct?
Okay.
So generating stimulus is a job given to one component, right? This generated stimulus is communicated to other components with help of mailbox. Now, what is mailbox? It's a pre-written construct. You don't have to write the methods in mailbox. You don't have to write what happens when you call a particular method. It's pre-written in System Verilog. You just have to know how to use the methods. So this is what System Verilog gives you. It gives you pre-written constructs which you can directly use if you know how to use them. So there is one component generating
Hello?
stimulus. Yes, tell me.
Can you tell me more about the mailbox? Not able to understand the concept that you tell now.
Yeah, a mailbox will be covered actually in much more detail later in theory sessions. This is just the gist. I'm just telling you that one component is generating stimulus. The other component will be using them to drive them to the DUT. But that component has to communicate the generated stimulus to the other component, right? So that communication is established by something called as construct, pre-written construct. That construct, you have to only know how to use it. Okay, you don't have to write that all. You have to just know. It's pre-written. So there are such constructs in System Verilog which are pre-written. You have to know how to use them. Okay, you don't have
Ma'am,
to
what?
actually.
Ma'am, by
write.
telling pre-constant, can you tell me in that constant what we easily write?
Can you repeat?
Means the word term you use the pre-constant. Mean what term you use? Not able to understand. Means why by telling this can what you are trying to explain?
Uh, did you hear what he said? You're actually not audible properly to me. Can you repeat your question or write that in message? Actually, it's better that way.
Actually, ma'am, you told a pre-constant that is written in the mailbox, right?
Pre-written construct. I said construct.
Yes, construct.
Yeah.
By construct, what is mean?
Yeah, I'll tell you. Pre-written method, pre-written code, pre-written piece of code. Code is called construct. Okay, so pre-written piece of code is called construct. You don't have to write everything in System Verilog. There are few things which are pre-written for you. You can directly use them. For example, if there was addition method, right? You must have designed calculator or ALU in Verilog, all of you, right? There was addition method. You were using the method. You were defining it somewhere else, but you were using the method. Now imagine you already have the method and you just have to know how to use it. You don't have to define it, right? So the definition is not required for you to write. It's pre-written in System Verilog. You have to know how to use it. And gate, right? These are pre-written things, right? If you can directly use and module with output comma inputs, right? These are pre-written things. You don't have to write the logic for it. You have to know how to use it. First, you write the output, then you write the number of inputs, correct? Right? So that's what construct means. It is pre-written piece of code that you don't have to write the logic for, you just have to know how to use. Is it clear? Hello?
Okay, ma'am. Thank you. Thank you, ma'am.
Yeah. So, where was I? Generated stimulus is communicated to other component with help of mailbox. Mailbox is a pre-written construct. You don't have to write logic for it. You just have to you just have to know how to use it. You will be learning that in detail later. Right? So this communication is stimulus is given to component dedicated to drive signal to the duty. Okay, this particular whatever you have communicated to the next component, that job of that next component is to drive that data to the duty one by one on the port, right? There is another component, other component has specific job of monitoring whatever is happening at the ports of duty. Monitoring and whatever is the signals being driven to the duty, this component has a job of saving them so that that data can be analyzed. If I'm writing something to the duty, I'm saving at what address, at what is the data that I'm writing, so that when I am reading out of the same address, I have that saved data to compare, right? So monitor's job is to save this data and forward it to the analyzing components, right? There are different components to dedicated or specific components dedicated to analyze. Analysis is also in different ways. A particular analysis is checking if whatever data is written, I mean comparing the data itself. At this address, this data is written. Is it the same data read from that address? That comparison is happening. So there is one component which is dedicated to just check how many correct data I have detected and how many wrong data. If there was some mismatch between the data, it is giving you only the number of matches and mismatches. A component dedicated to do a particular job. It doesn't have to get burdened with doing everything else, right? The way you can think of one big house, again house analogy, where everything is in the same room, kitchen, bedroom, hall, everything in the same room, and one house where different things are done in different rooms. Which one you think is convenient? Different rooms, right? So the same way System Verilog helps you to compartmentalize or modular, make it modular, make the verification process modular. There is one component dedicated to do one job. Is it clear? And saving the data given to the DUT. So this saved data is given to the analyzing. Monitor is not analyzing anything. Monitor is only saving the data and giving it to the analyzing components. Okay, analyzing components. So let's look at the test bench architecture. So there is architecture, meaning there is a particular structure for writing test bench. You don't have just one module doing everything, right? You have a structure. So you can see there is DUT here, right? So there is DUT here, right? DUT, you can see on the left side, there is scenario generator. This one, right? This is the generator I was talking about. There are test cases. According to test case, it is generating scenario stimulus. Those stimulus are in form of objects. It is with respect to the object-oriented programming. You will know what objects are in later sessions. But know that objects and signal, object level communication and signal level communication. Your module expects signal level communication. You have design module. It expects you to give address signal separately. It expects you to give data signal separately, valid signal separately. But object communication is all of these things are bundled together as one stimulus. So a combination of address, data, valid is one object. So scenario generator will be generating the scenario in terms of objects. These are bundled to, you can think of them as bundled together all the signals. These are not separate signals. You cannot drive entire thing to the DUT. For driving to the DUT, you need to convert this object level data or stimulus into signal level stimulus, right? So through mailbox, this object level data is given to something called as BFM, which is bus module, bus functional module. Why bus functional module? Because it converts that object level data into signal level data. You have bundled address data valid, it will separate address, it will separate data. At valid equal to high, it will put the data on the DUT. So it is changing the data here, not changing the data values, but format of the data. We had a bundled up data coming to the BFM. It is separating it into the signals and putting it on the DUT ports, right? You can see there is monitor component, which is looking at the signal ports of DUT. There is only one arrow drawn here, but you can see that single arrow represents all the ports. Okay, so what is happening here is monitor is monitoring whatever data is being communicated to the DUT, whatever data is being driven to the DUT. Now there is one link missing here. There should be another mailbox. So what monitor does is exactly opposite. I'm sorry. Exactly opposite of BFM. It takes signal level data, bundles it up in object level data, and it communicates that object level data through mailbox to analysis component, which is functional verification, functional coverage, reference model, right? So checker, right? So the job of functional coverage is to check if I am covering all the features. What are features of the memory? You should be able to write into it. You should be able to read from it. There are different address ranges. So what you are checking in memory is if we are able to write into the memory. Is write read signal being used? It won't check if it is actually writing into it or not. It will just check if that signal is being used. So variation in that signal is happening or not, that will be checked by functional coverage block. Variation in address signal, the address is 32-bit long, whatever number of bits long. Is that value changing? If it is changing, is it coming into a particular range of addresses? So all of that is job of functional coverage. It will cover if a particular feature is being exercised or not, right? Reference model will, on the other hand, what it will do is it will have the expected behavior. If I'm writing a particular data into it, when reading, it should be present from that particular address, it should be present. So reference model will give you expected behavior. If my DUT is addition, right? 1 plus 2 is 3. When I'm sending 1, 2 signal to the DUT, output should be 3, right? Reference model will have that written into it. If I'm giving 1 and 2, it will have output 3 to compare with it. So there has to be expected output and actual output. DUT will give you actual output. Reference model job is to produce expected output, right? So it actually has that expected output through the monitor data. Monitor knows what data is driven to the DUT. Reference model will calculate what should be the expected output on its own. It will be similar to the DUT functionality. It will save those things. Now this is what I'm expecting as the output. Checker will check if that data is matching. See, there is another component here. Checker will check if that data is matching. Whatever you are writing into it, is it reading? It will check. Reference model will just
Excuse me, ma'am.
produce the... Yeah, tell me.
Excuse me, ma'am. Can I just tell, what will that reference model register do? I mean, reference model will do, the previous one. Yeah.
Yeah, reference model will produce expected output. And checker will verify if it is matching or not. If it is matching or not, it will give you the number of matches and mismatches. Scoreboard will simply tell you what is the number of matches, what is the number of mismatches. Is it clear? So you can see every component has a particular job and it is connected to the DUT as shown in the figure. This is again interface. When you look at this, it has to be two-way interface because our DUT has both input and output, generally input output both direction ports, right? So it is two-way, what can we say, something called as interface. That will also be covered in theory sessions. What is interface, why we require it. So DUT is connecting to all the other components in this way. Monitor and BFM are two components which are directly interacting with the DUT. All the rest are interacting with monitor and BFM, right? Generator is interacting with just BFM, right? All the analysis components are interacting with monitor. Correct? Now, assertions is something signal level verification. It is again a separate topic in verification. So we will cover that with sessions as we go further. So this is what test bench architecture looks like in System Verilog. Is this clear? Are there any doubts here in the test bench architecture? Whatever I have explained. Go through the diagram, let me know. Online people? No doubts? When we learn any language, you have learned Verilog, right? What was the first thing that you learned in Verilog? What was the first thing that you learned in Verilog? When we learn language, what do we learn first? I'm sorry, can you repeat? Louder, I'm not able to hear you. It's correct. Tell me. There was some answer from here, some from here. Tell me. Syntax. And
Structure of the program.
what? Can you repeat?
Structure.
Right. Data types. What all we can use, right? What all data types are there? So let's see. First thing in System Verilog also that we'll be learning is data types. Literals. Do you know what are literals? What are literals? Yes. Literals are rules, right, as to how to assign values to the variables of those particular data types. If I'm saying data type is reg, then there will be rules as to how to assign reg values, right? If I say data type is string, is it possible in Verilog? String data type? No, but can you assign string value to some other data type? How did you write test cases? Right, so there are rules.
String.
Right, string. There was how to assign string value to reg variable. That there was a rule there, right? You need to write it in double quotes, right? So literals means rules as to how to assign values to your variables, right? So first thing in System Verilog that we will learn is these rules. Okay. Now, first thing that you need to understand here is in Verilog, all the data types present in Verilog are also present in System Verilog. On top of it, there are more added for ease of verification, code writing. Ease of code writing. Right, so everything that is present in Verilog is also present in System Verilog. Plus, there might be few things added to the same construct, or there might be few extra constructs added. For example, there is no concept of mailbox in Verilog, right? There is no concept of interface in Verilog, right? But you heard these two new words in System Verilog or test bench architecture, right? So there are more constructs added than there were in Verilog. You should know that Verilog is what can we say, subset of System Verilog. Is everything in Verilog synthesizable? No, right? Do you think is everything in System Verilog synthesizable? Because System Verilog is basically for writing test bench. Do we synthesize things in test bench? No, right? Are we required to synthesize? So are all the constructs in SV non-synthesizable? Do you think all the constructs in System Verilog are non-synthesizable? Yes or no? No, right? No, because all things cannot be non-synthesizable as well. I told you everything in Verilog is present in System Verilog. So if you want to use always @ something in System Verilog, you can. That will be synthesizable given everything that you are writing under it, under that procedural block. Everything, if it is synthesizable, that procedural block will be synthesizable, right? So depending on what you are writing, SB code as well can be synthesizable, right? Is it clear? Let's go through these questions. Functional verification overview. Term verification have different meaning for different engineers in VLSI flow. Why functional verification is required? Why do you think functional verification is required? I want answers from you people. Online people, you can answer in messages. Why do you think functional verification is required?
Check the behavior of the circuit.
Correct. What else? Something to be added to this answer?
To check the functionality, like it matches to the expected output.
Correct. Any design will have a particular number of features. Like, can I say that if out of 10, 2 features are correctly working, can I say the design entirely is working?
No.
Yeah, please don't send private messages. I have to open it and then I cannot see the next messages updated. Send any messages in everyone's chat only. Okay. So any design will have a particular number of features. All features have to be working according to the expected functionality. Even if one fails, do we call them verified design? Even if one feature fails, can we call it a verified design? Functional design? No. What we have to say, there is a bug. It needs to be fixed, right? Can I go out and sell a laptop which is working, everything else is working fine, but touchpad is not working? Can I sell that? No, right? It has to be working. Even one feature. If I'm adding that,
You
this
can
is the
sell
feature.
for less price, ma'am.
I'm sorry, can you repeat?
You can still send the laptop for less price, ma'am.
Yeah, no. No, because if whatever I have written in code, the same thing will be given to hardware manufacturing, right? So I will not be manufacturing single laptop with not working touchpad. It will be multiples, right? I won't be creating one laptop. It will be in the range of lakhs, right? The chips will be created in the range of lakhs crores, right? So is it a profitable thing for the company if I do send this? Okay, this is verified design. No, right? Is it clear? Person who asked the question?
Yes, ma'am.
Yeah. Design cannot be passed or design cannot be passed, right? Or manufactured. We need to fix the bug. That feature needs to be fixed before sending design forward. Correct? So, why is it required? Why functional verification is required? For any design which is written, if we are saying that there are 100 features, all 100 features should be working at the expected or specified capacity, whatever they are saying. If I'm saying that I have capacity of this speed of my internet, I should be able to give that speed hardware wise, right? Let's see. Inputs to functional verification engineer, various steps in functional verification flow. How do we develop test bench for any duty? Yeah, can you tell me various steps in functional verification flow? We just discussed it, right? In the starting of the class. First, we need to
Generate.
make a list of features. What next? Come up with test cases that we might need. If we think of memory, right, there are two features: writing into the memory, reading from the memory. So we come up with test cases for that, right? Front door, back door won't be a working test case, but front door writing and reading are the main test cases, right? So what do we do? Come up with required number of test cases for verifying all the features. Correct? What else? What do we do next?
Hello, ma'am.
Implement. Yes.
What is front door and back door?
Front door meaning the data transfer which is happening through the ports. Back door is not a practical way of writing or reading from the memory. It's like directly accessing the memory space and putting the data in it manually without having to go through the ports. So it's not practical use. But in verification, if you have verified that front door ports are working the way they are supposed to, it saves time in verification. Memories are used in various designs as just extra thing, right? Actual design feature is different. Memory is extra thing. So I might need to write into large memories, large number of data. I don't want to do it through front door because it's going to take up a lot of time to write entire data. So backdoor helps in saving time in verification. Once we have verified the front door ports are working fine. Is it clear?
Okay, ma'am, it's clear.
Yeah. It will be clearer, I think, when we are verifying memory with system Verilog. At that time, it will be clearer. Come up with required number of test cases for verifying all the features. What next? Implement all the test cases one by one and drive one by one by driving data to the duty. What next? Analyze the functionality, right? Whatever data transfer is happening to the duty, analyze that, right? Analysis of the data driven. So analysis has more sub analysis components in it, right? There is functional coverage. There is code coverage. And then we have reference model, that is data comparison, right? There is checker and scoreboard. What do they do? Give number of passed and failed data comparisons. This particular component will keep track of that. Functional coverage, what will it do? Check if a particular feature is verified. What will code coverage do? It will check if in design a particular procedural block is executed. Code coverage is important for design only. We will know that in more details in coming sessions, but this is basic of it. Okay, so analyze the data driven. What next? If any of the above analysis is failing, redo to get passing analysis result. So if there are design bugs, you send it to the design team, ask them that this is the behavior. If it is test bench bug, you need to write test cases in a better way. There are two ways you can fix this. If design bug, send it to the design team to correct. If TB issue, write test cases properly. Correct? So this is the process which is going to go on continuously till the time we have verified all the features, these 3 lines. Till we have verified all the features and we are getting passed test cases. All of the features are passing. All the analysis components are passing. Okay? Clear? So these are various steps in functional verification flow. This last step happens in a loop till the time we get finally verified design. Is it clear? Clear, everyone? Online students? Okay. How do we develop test bench for any DUT? I think answer will be for any DUT, we'll be doing this, right? We'll be following these steps, functional verification flow steps. Different components in test bench. Yes, can someone tell me different components in test bench? We have seen that in the morning, right? At the start of the section, right? Any name that you remember, what are different components in the PB structure or architecture? Yes, everyone respond. You can make a list on your paper if you want to and read it out later. Online students, put a message. What all components in test bench architecture we have learned? Make a list. Once you are done with your list, read it out. Make a list. Make a list on paper. Once you are done, read it out. We saw that in the starting of the session, right? All the components. Online students, put a message. What all components we saw in test bench architecture? I'm getting no response from online students. Why is it so? Am I audible fine? Yeah, try to come up with your own list. You don't have to come up with all, right? Whatever you remember, you can write and read out. As we go further in the course, you will know them by heart. Correct, Vijaya Lakshmi. 3 of them, functional coverage. Test cases. Okay, duty is design itself. Okay. It's slave model actually. It depends on the design if you require slave model or not. But all the rest of the components will be there. Yeah, what about others? Only 2 people online, 3 people online are responding. Please do not send private messages. It's difficult for me to open and then I don't. I don't get updated messages.
एक काम कर, तू आजा, मैं आ रहा हूँ, सीधा ऑटो पकड़ा दे।
Yeah, anybody offline done with your list? You can read it out. Anybody done with your list? Read it out.
Mailbox,
Mhm.
monitor,
Mhm.
scenario generator,
Hmm.
functional coverage,
Mhm.
checker,
Hmm.
scoreboard, assertions,
Mhm.
slave module,
Mhm.
reference model register.
Anyone else? Whatever you have written, you can read it out. Mhm.
Simulation generator,
Mhm.
core cover, core checker, DUT,
Mhm.
monitor, core mailbox.
Mailbox is not one of the components, but all the rest are components. Anyone else done? Hmm?
Driver monitor,
Hmm?
reference module,
Hmm?
DFM,
Driver actually is BFM, driving data to the DUT. Score. Okay, done with the list? Anyone else? Yeah.
HTS, DFM,
Mhm.
monitor, DUT, scoreboard, checker.
You can you can go through PPT once you're home, and you will know which ones you have missed and which ones should be added to the list. But most of you did correctly. Can you read it out? You after him. Yeah.
Clock generation.
Mm-hmm. It's not a module, right? Clock generation or test bench component.
Signals.
Hmm?
Yes. AFM.
Mm-hmm.
Code checker.
Okay.
Code coverage. Monitor. Scoreboard.
Code coverage is not one of the components. It is tool generated. Okay. Yes.
DFM.
Mm-hmm.
Monitor.
Mm-hmm.
Scoreboard.
Mm-hmm.
Test cases.
Mm-hmm.
DUT. Checker.
Yes.
Monitor, reference model, checker, scoreboard, assertions.
Ladies on right hand side. Yeah, both. Ladies. Yeah, both of you.
Functional coverage, reference model, mailbox monitor, checker, scoreboard, scenario generator, VFM test case.
You?
Monitor, checker, test case, functional coverage, scenario generator, scoreboard, reference model.
Now, the thing about test cases, everyone has written test case as a component. I think there should be, here also, there should be clarification. Based on test cases is something we list first, what all we are going to require. But scenario generator is going to implement those test cases. Test cases is not a separate module. Scenario generator will be implementing them. So you can just say scenario generator instead of test case separately. Okay. Test cases is just a list of test cases. It's not a component implementing or writing the logic for it.
Excuse me, ma'am.
Yeah. tell me.
What is assertions, ma'am? How about assertions?
Yeah, assertions are direct signal verifications. I mean, verification happening on signal level. So they are directly connected to the duty. Assertion is also something, see, out of all these components, BFM monitor and assertion, 3 components are directly communicating with the duty. All the rest are communicating with each other. So signal level verification meaning directly, instead of waiting for the signal to reach the analysis component and then complete the analysis, and then we getting to know that there is an error here in this signal. Assertion detect the error at the starting only, at the interface only. If they see something incorrect happening, that logic we have to write. What is incorrect, that we have to write. But if they see that happening, they will raise the error, stop the execution. It will not complete, it will not, assertion error will not let the verification or simulation complete. It will stop the error then and there. Okay. Okay, only few people from online are responding. Okay, is your doubt clear?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
It will be covered later in detail. It's a whole topic. I think it will take 2 to 3 days. And let's go to next question. Scenario generation components. So test case and scenario generator. Test case is basically just the list of all the test cases. Checking components. Can someone tell me what all are checking components? Analysis components, basically. Make a list again. What all are checking components. Online students, put a message. Yeah. Just one?
तो मेरे को तेरे को बोला था भरे हुए ऑटो में बैठना, तभी तुम कह रहा हूँ भरे हुए ऑटो में बैठ। हाँ कोई नहीं, आगे चल, आगे जा, मुझे पता है
Yes, done.
Checker, scoreboard, reflex.
You.
Checker, scoreboard. Checker, scoreboard.
Checker scoreboard. Checker scoreboard
Monitor. You.
Checker scoreboard monitor.
Monitor.
Checker scoreboard. Functional coverage checker scoreboard. Functional coverage checker scoreboard.
Checker, scoreboard.
Yes.
Checker, scoreboard. Checker, scoreboard.
Scoreboard reference model. Monitor. Checker.
Yes.
Functional coverage reflection modifier scoreboard. Functional coverage. Functional coverage assessment checker scoreboard.
So people who told monitor, monitor is not an analysis component. Monitor's job is to just monitor the interface, save the transaction and forward it to the analysis components. Okay. All the rest are analysis components. Which ones? Functional coverage, reference model, checker, scoreboard. All four. Assertion is also analysis only, but it's signal level analysis. Right? Okay, tell me modularity and reusability. How do we see modularity and reusability in System Verilog? You can skip reusability answer, but you can try answer for modularity. You can tell orally, you don't have to write it. Online people, you can put a message. What is modularity and reusability in System Verilog? Think about it and answer. When you have constructed your answer, just raise hand, start talking. No, there is no relation in between checker and assertion. Assertion is standalone module itself. Online students, you can put a message. Modularity and reusability. You can skip answer for reusability. Try answering for modularity. You want to talk?
Some system components for a specific kind of task, like for scenario, for stimulus industry, we have
A particular specific component.
generator, and for driving the data into the DUT, we have a driver, and saving the actual output data from the DUT, we have monitor, and for giving the result, we have a scoreboard, like that, we have different components.
Correct.
Modular.
Correct. Anyone else? See, if you try answer in the session, na, you will get that confidence in answering in the interview. And it's very necessary. Everyone is learning here. No one is going to judge, okay, what he said, what she said. So try answering. Multiple components are present in the design where specific job is assigned to the particular component can be defined as modularity. Correct. Organizing code in specific manner. Yes, but that manner you have to elaborate the way it is elaborated here. Give specific job to specific components. Correct. Yes, anyone else wants to answer? Yes. Try. Try whatever you have learned, that only you have to say, right?
Combines different components. Every component has its specific job. By using blocks, we can communicate with one component.
Correct. Correct. So specific component is given a specific job, right? In the verification flow. Scenario generator has specific job of just generating the scenario, nothing else. BFM has specific job of driving the signals to the DUT, nothing else. Monitor will do opposite. It will monitor the signals and save the data from the DUT. Input output both signals monitor will be monitoring. Okay. Analysis component. Specific analysis will be done by specific components. Sorry. Okay. When do we close functional verification? This is simple. When do we say that we are done with functional verification for a particular design? Yes. From all the features. We have verified all the features and we got expected output from all the features, right? Yeah, there is this traffic light controller. We can, yeah, I want you to, we have gone through memory or basic test bench architecture, right? When you go home and open PPT, you will find an example on TLC, traffic light controller. I want you to go through those few slides and try and understand the test bench architecture, test bench flow. In next session, you will tell me what you have understood. Okay? I think slide number 17, 18, 19. Yeah, 3 slides. Go to slide number 17, 18, 19. To understand the TP flow. In next session, we will discuss it. Okay? Can functional verification be done with Verilog alone? Yes or no? Yes or no? Can functional verification be done with Verilog alone? Yes or no? Yes? Complex. Probably. Yes, but it will be difficult with respect to system Verilog, right? As we go further, you have done functional verification for few designs yourself, right, in Verilog. But as the design complexity increases, the test bench writing is also going to increase. Right? The feature checking and all, that is going to increase. There are some, I think, functional coverage and all is not even possible. So there are few aspects of the design which will be left unchecked. So yeah, it's not actually with Verilog alone but for complicated designs with more features. Simple ones are possible, right? With few number of features, it's possible. You have done that yourself. But as the number of features increase, the complexity is going to be increased in writing test bench in Verilog, and maybe few aspects are not even possible, right? How SV and UVM help? In both SV and UVM, we have pre-written constructs which we can directly use, right? In UVM, we have pre-written methods, pre-written components we can directly use, right? In both SV and UVM, we have pre-written constructs. In SV, we have constructs. In UVM, we have codes. We have components all together, right? In UVM, components all together, right? Pre-written. So we can directly use them. Right? So it saves time to write long codes, right? Simpler to write logic with rewritten constructs. Okay. Yeah, these things will be covered later as we go further. Just keep in mind that there are few questions left to answer. As the course goes further, you can come back to this slide and try answer more and more questions. How to use QuestSM and all. See, all of these will be done in lab, right? Once you start using all those tools. So keep coming back to the slide once you get to know the answer to one of these. Come back to the slide, try to answer. Put in, have a paper which has, or couple of, or notebook which has all the answers, right? One of these or more than one of these questions will be for sure asked in your interview, right? So have answer ready. If your answers are already arranged in ordered way, it will be better, right? So have notes for these questions. Keep coming back to it as the course covers some topics. You can keep filling in the answers. Okay. In already written answers also, if you feel like adding something, you can add it later, right? Okay, then we can stop actually this session here, because next part includes actually going through the starting the concept itself. So we will start the concept in can't we use model sim for system Verilog? Yeah, for basic codes, yes, but there are some constructs which model sim tool doesn't recognize in system Verilog. Right, so no, model sim is not recommended for system Verilog. We need entire analysis components like functional verification, functional coverage and all. I don't think model sim allows that. It's a free tool, right? It's open source, right? So no, not open source, free tool, but you won't be able to analyze. Some aspects of analysis are not available. Okay, then what we can do is we can stop the session here. We'll continue in next one. Okay. Any doubts? Any other doubts?
है वाई जीसीपी का सॉफ्टवेयर है जिस पर मैं काम करता हूँ वैसे तो वेब उनका वेब
No doubts? Thank you, everyone.
अरे इनका खुद का पोर्टल है
This conference is no longer being recorded.
रिकॉर्डिंग चल रही है अरे टैब चल रहा है
You have lab session today, right?
दो लाइव मीटिंग चल रही है एक लीड लाइव मीटिंग ये चल रही है वो कल वाली
So it will be scheduled. Keep looking at WhatsApp group for the schedule. Okay. Okay, then thank you.
असल में वो पूरा टाइमिंग वॉचिंग टाइम पूरा करना पड़ता है उनको पता उनको लगा कि कल भी नहीं देखा मैंने आज भी नहीं देखा ऐसे जैसे हो गया हो गया हो गया।